Good afternoon, professors. Welcome to third session of ADT. I welcome Dr. Saravanakumar Sir, C, Associate Professor, Department of Information Technology, St. Joseph Institute of Technology. He has totally 16 years of experience in teaching and research. Has completed real-time project in the field of cloud computing, A and ML, and has published more than 30 plus papers in international conferences and 20 plus in international journals. His areas of interest and skills are cloud computing, AI, ML, data science, Amazon Web Services, Jenkins, continuous integration, continuous delivery, GitHub, Prometheus.io, and Grafana. I welcome you for this FDDP, sir. Yes, let me solve your story from start this session, sir. Sir, it is. Sir, it is visible, sir. You can go ahead.
Professors, which is right. So the topic is ADT applications. So this is purely a data structures concepts. We are familiar with that. So data structure is organizing a data, right? So every data structure concept is based on insertion, deletion, and finding, searching. So these are all the basic operations we have to perform over any data structure operations. It differs based on the algorithms we are applying, right? So we are familiar with that. The data structure is classified into two types, linear and non-linear. We were studying in previous sessions. So this queue is basically a linear data structure, right? So it follows first in, first out, right? So previously we used stack. Now this topic is fully based on queue. How the queue is works, what are the concepts, and what are the types of queue, and where we apply that queue in real time or any applications, right? So normally queue, ADT is abstract data type, right? So what is abstract data type? So the implementation details are hidden from the users. The best example is header files, right? Header files, let us take in C header file, stdio.h. So if you want to perform input and output operations, we need scanf and printf, right? So we don't know the internal design details of scanf and printf. We simply pass our parameters, right? So that function gets invoked. So that is belongs to stdio.h functions, right? So this is actually a IO functions, especially related to our stdio.h. So that is also a best example of abstract data type. We don't know what are the implementation details of scanf and printf. We don't know how the parameter is organized, how the coding is done. We simply know the functions based on our variables, right? So you can pass input as a integer, float, or string, whatever it is. And we can use any number of values, right? Input parameters. So this is actually a abstract data type. So queue is also implemented using abstract data type. We can directly use insertion, deletion, and whatever we need operations, right? So queue is normally a linear data structures, the way of inserting and deleting a data from the memory in linear fashion, right? So here you are studying in previous sessions, stack. Stack is also a linear data structure which has only one end. So that end especially for storing and inserting and deleting a data. So we can keep only one variable called top. So if you want to insert any element, we increment the top by 1, right? And if you want to delete an element, we decrement the top by 1. So we keep only one variable because we keep only one end. The same end is used for insertion and deletions. Whereas Q is a linear data structures. We have a 2 end, one end for insertion, next one for end for deletion. Right? So here we need to keep 2 ends. That's why we are implementing 2 different variables. One is a rear, next one is a front. Right? Whereas stack, we have only one variables, that is called stop. Right? Because we have only one end. Whereas Q, we have 2 ends, we keep 2 variables. One for insertion, next one for deletion. Right? So the insertion, deletion are performed in 2 different positions based on the rear and front variables. Right? So the insertion is done at one end and deletion is done at another end. So while inserting an element, we use a rear. It takes care of all the insertions. Whereas the deletions is done through front. Right? So stack always follows, Q always follows first in, first out. The first inserted element is deleted first. That is called first in, first out. Whereas stack, it's the last in, first out, right? Last inserted element is deleted first, right? So this is a FIFO concept. So here this is one representation about the queue. So the front and the rear. Rear for inserting and front for deletion. Right? Now the definition about the queue. So normally we are familiar with that. Queue is a linear data structure in which the operation is performed in FIFO manner. First in, first out manner. First inserted element is removed first. Right? So the queue also holds the similar data items, right? It cannot hold different data items. It can give only similar data items that performs in FIFO manner. Right? So normally any data structure operations is done through insertion and deletions, right? Here in Q, there is a concept called NQ. NQ is used to insert an element in the queue. So normally stack uses push for insertion, pop for deletion. Here we use NQ and DQ. So NQ for inserting an element, DQ for deleting an element. Right? So while performing NQ, we can use rear is a variable. If you want to perform deletion, we use front is a variable. So that is a marker to hold all the constraints for insertion and deletions. So participant, do you have any doubt or clarification? Feel free to ask. Right? So this is the 2 operations. NQ is the insertion and DQ is the deletions. And during the insertion, we have NQ, we pass one value. So that value is placed over your Q, right? Suppose if you want to insert 10, so definitely the 10 is inserted into Q. So that's why we pass the variable. So the NQ function has a parameter. The parameter consumes the value from user and that is inserted into the queue. Whereas DQ, we don't want any parameter because whenever you perform DQ, it automatically removes the first element. Right? So display also no need to specify any parameter, because what are the values available in the queue, so that is displayed by this function. So normally we have a insert, delete, and display. Sometimes we use search. If you want to search any element from a queue or stack or whatever the data structures, right? So this is actually a functions MQ, DQ, and display. These are all the operations of queue. And assume that this simple example for the queue. So if you want to insert 21st, 25, 25. After 30, it is in the next position. 51 is in another position. 60 is in another position. 85 is in another position. Which means that whenever we insert an element, we increment the rear by 1. Right? Because the rear is moves from end to end. For example, here, if I want to insert 90, so definitely that rear is moves to here, and we can place the 90 here. Right? Next 95. Definitely that is also moves the rear to another position, and we can place 95. So this is the way we need to insert any element. Which means that whenever we insert an element, so we increment the rear by 1. Rear plus 1. The rear is in current position. For example, here it is a 0, 1, 2, 3, 4, and 5, 6. Suppose if you want to insert 100, what is the current position of rear? It's a 6. Now 6 plus 1, so it is 7, right? So that 7 is the position where the new element gets inserted. Now the rear is moved to 7th position. Now we can insert 100 here. So this is the way we need to insert any element. Is it clear? Okay. So this is a basic idea about the queue. We'll discuss later how to insert an element and how to delete an element. Right. So this is a simple queue which holds 5 elements, right? So types of queue. So there are 4 types of queues which applies in real-time applications. Simple queue, so that's a linear queue. Next one is a circular queue. We'll discuss what is the difference between the linear queue and circular queue. And priority queue, you can apply some priority over the elements. And double-ended queue, right? So simple queue, it holds the values based on the FIFO order, whereas circular queue, so it forms a circle. The last element is connected with the first element. So there is a problem in linear queue. So that is overcome with the help of circular queue. And also priority queue. Some of the real-time applications, we need some priority over the items. For example, if it is a batch processing jobs or multi-programming, so definitely we need to allocate some priority over the jobs or process. So higher priority gets executed first by the processor. Likewise, here also we need to specify the priority over the data items through key and value pair. So the elements with the priority is called priority queue. We'll discuss. And double-ended queue. So normally we have 2 ends. One for insertion, another for deletions. We cannot use insertion n for deletion, deletion n for insertion. So there is a restriction, right? Whereas double-ended queue, we can perform both the insertion in both the ends. We can use front for insertion and deletion, rear for insertion and deletions. So for that purpose, we use double-ended queue. So these are the types of queue. So this session fully based on these 4 types. So any data structures is implemented in two ways. One is array based, next one is linked list based. So array, so while implementing a queue in array, first to declare one variable, that is a array variable, integer, a, or any data types, 5. So it holds 5 elements, right? So normally this is a characters, it's normally a string. So that is stored in the array. Hello, H is in the first position, E in another position, L is another position, L, O. How to do it? So array, first to declare array, and we can start with the 0th position because array starts with 0 to n minus 1. Right? So totally, according to this example, we can start with 0 to 4. Right? So totally 5 elements. So this is a representation for element 6. Number of element is 6. The queue array size is 6 because it started the 0 to 5, totally 6 elements. Right? So this is actually a static size. We cannot extend 5 to 10 or 5 to 3. We cannot extend. Right? So because it is a static, it's a fixed. So linked list is another way of representing a queue. So this is a linked list. It's a simply linked list, right? One element is linked to another element, right? Because our element is scattered over multiple or different places in the main memory. If you want to make a link between these data items, which forms a linked list, right? So this is the first element, and here we can use the first element is a front and last element is a rear. So these are all the two implementation related to queue. Not only queue, we can apply all the data structure operations. For example, if it's a stack or queue or tree. So common implementation of queue is array-based implementation and linked list-based implementations. Any doubt? Is it clear? Okay. So first, let us start with array-based implementation. So normally the queue data structure is implemented using one-dimensional array because we have only one dimensions, right? We don't have any dimensions. So for example, integer a of 10 or 5, right? So this is a one-dimensional array because we have only one subscript. We can keep all the elements up to 0 to 9. And the array stored only fixed number of data values. What's the meaning of that? So we can keep only the 10 elements. We start with the 0 to 9. Apart from that, we cannot insert because the size is fixed. In terms of implementation, the array is very, very simple, right? Because we create one array. After we can easy to store an array because it is simple. There is no any complex concept. We don't want to implement any memory management functions. We directly declare variables, array variables, and keep our data in the respective order. That's the FIFO order, right? So we just define one-dimensional array with specific size. So during the insertion and deletions are done in FIFO order through two variables. One is the front, next one is the rear. Because we have two ends, right? This one end is another end. One for insertion, next one for deletion. So initially, these variables. So these are the variables. It is like a simple integer variable which gives the position of the actual insertion element or deletion element. Right? So initially, this is set to -1 because the array starts with 0. Assume that. So here it starts 0, 1, 2, and 3, 4, up to 9. right? 9 elements. So here, this is the lower bounded is -1, -2, like that, right? So in array implementations, we can start with the rear and the front in -1 because our array bound start with 0, right? So rear and front are start with this position, right? So whenever we insert any element, we have two conditions. While insertion, we can perform rear plus plus. So increment rear variable plus 1. That is called rear plus plus. Or rear is equal to rear plus 1. So initially it is -1. If you want to insert a first element, you can increment by 1. So initially it is -1. That is incremented by 1. It is 0. So that moves to first element. Now we can place our element in this position. Right? So for that purpose, initially we keep our front and rear as -1 position. Right? So if you want to insert any new value, you can increment the rear by 1. So initially it is -1, it goes to 1. -1 plus 1 is 0, is the first position. If you want to delete, delete also performs front plus plus. Assume that f is a front plus plus. Initially it is -1 and plus 1 0. So we can remove the first element. Right? So this is actually a case we perform insertion and deletion through array. Right? Now, so some of the steps we have to follow to perform the array operations. Initially, we need to create one empty queue, right? So because we need one array, that array has some sizes, right? Assume that this is a 4, 0, 0, 1, 2, 3, 4, totally 4 elements. 0, 1, 2, 3, 4, totally it is a 5 elements. Array size is 5, right? For example, in this equal to 5, that is an integer type, right? So while implementing an array related to queue, first include the necessary data files. What are the data files we need? stdio, that is for input and output, and some related data files. So we need to choose what are the data files we need and fix the sizes constant size. For example, yes, there is a preprocessor value, size is 5 or any specific value. Based on our requirement, we can specify, right? And we declare the user-defined variables or functions for queue implementation. What are the user-defined functions? enqueue, dequeue, and display. If you want to search any element, you can perform searching, right? So based on the above parameter, we need to create a array. So size, for example, here it's a 5. Here 5. Otherwise, we can use some size. Declare the size as a 5, that's a constant. You can pause the size. So now this is an array, right? So this is an array with the size. Size is a 5, for example. So we need to declare two variables, integer front and rear, right? That's integer type. Now we set with the -1. So front is equal to -1, rear is equal to -1. So now the declaration part is over. Now we need to perform the actual process for these things, right? Insertion and deletions. That's enqueue and dequeue. I hope you are understand the concepts. Do you have any doubt? Please share. Right. So here, so this is actually a simple enqueue and dequeue operations, right? Initially the front and rear is -1. So this is our array. Initially all the arrays empty. So this is array 0, array 1, array 2, array 3, array 4, totally 5 elements. So while inserting 10, right? It is not a 2, it is a 10, right? Now we need to create increment rear value. Initially it is 0, right? So now this is -1. Now the front and rear are is in this position. -1, right? Now we need to move to this position, front and rear. How to move it? We need to perform increment. Initially front is -1. We can perform increment because whenever we perform insertion, right? Assume that it's a rear, right? Because it is an NQ operation, right? So 0. Now the R is moved to the rear, is moved to first position. That's 0th position. The same way we need to increment front value because while deleting an element, the front also point towards the first position. Then only we remove this 10. So we need to increment that front also, -1 plus 1. Now the front and rear are in the first position. That is 0th position. Remaining things, remaining places are empty. Right? After that, if you want to place 20, assume that it is not a 4, it is a 20. Right? It is not a 2, it is a 10. Now we perform NQ. NQ means insert. Now we need to perform increment by 1, rear plus plus. Right? So initially rear is now, the rear is 0, right? So rear 0 plus 1 is 1. Now the rear is moved to first position. We have 0. Now we can place our 20 here. Likewise 30. So this is a 10, this is 20, this is 30. Right? How to perform 30? Insert 30. Again, the rear is incremented by 1. Now the rear is 1. Again 1 is 2. Now the rear is point towards 30. Likewise, it insert 40 also. 10, 20, 30, and 40. So NQ 40. Again, 2 plus 1 is 3. Now the third position holds 40. So this is the way we insert an element. Right? This is called NQ in the queue. So please keep in mind, whenever we insert an element, we increment here by 1. So according to deletions, we perform DQ operation. So initially it is, okay, can keep as it is, 2, 4, or otherwise we can use the same value, 10, 20, 30, and 40, right? Now, so now this is our end. The front point towards the first element, rear point towards the second element. This is a position where front and rear appears. This is actual queue, right? Now if you want to perform delete, how to perform delete? We need to increment front plus 1. Initially front is 0, right? Initially -1. After inserting a first element, we increment by 1. Now it is 0. Now it is increment by 1. Now it is 1. Now we can remove this. Now front is moves to first position. So that is 1. It moves to first position. Now the queue has 20, 30, 40. Right? Now rear and front. Again, we need to perform DQ. So NQ needs, we need the parameter. DQ, we never use any parameter because DQ automatically removes the data from the front position. Right? So this is the way we perform in NQ and DQ operations. Right? So while performing NQ, we can increment rear by 1. While performing DQ, we increment front by 1. And also we check the overflow and underflow conditions. Assume that now we have only 5 elements. After inserting a 5 elements, we cannot insert new element in the 6th position because the array is static. We can use only 5 elements. So up to this, it is fixed. If you want to insert 6th element, we cannot insert because there is no space. The size is only 5. So this case we get overflow conditions. So while inserting an element, we get the exceptions called overflow. We always check if the queue is overflow or not, or is full or not. If it is full, we cannot insert further. Otherwise, we can insert. Likewise, while deleting any element, we need to check whether the queue is empty or not. So if the queue is empty, we cannot locate any data because already it is empty, we cannot delete. So while performing DQ operations, you can always check whether the queue is empty or not. So these are the two exception conditions you have to check while inserting and deleting any element in the queue. Now inserting element. Now, so see here, this is our program. These are NQ operations. Here I'm using C program. We can convert this into C++ or different languages, right? So while performing NQ, we insert a new element into queue, right? So we always insert a new element in rear position because rear is the position where our new element is to be going to be inserted. So this function takes one argument, that value is integer value. So that value is inserted into queue, right? So while performing insert operations, we have to check whether the queue is full or not, right? So if the queue is full, we cannot insert because it is an array-based implementation. Array is a static, right? If it is full, we can simply display one error message that is queue is full. Insertion is not possible message. We simply terminate our function. If it is not done, we can perform further operations by incrementing rear by 1, and that position we can insert our new value. These are the steps we have to follow while inserting a value in the queue. Assume that if you want to insert 10, so the 10 is actually input value. Now the size is 5. First you check the full condition. Size minus 1. Now size is 5. 5 minus 1 is 4. Right? Because it is array. It starts with 0. 0 to 4. Right? So we can check. It goes beyond that limit. It reaches 4. If it is full. Right? We check. If it is not full, we need to move front to 0. So here, initially, the front is minus 1. Right? While inserting an element, we need to move to 0th position. Then only we can remove the first element. Right? That's why we check if front is equal to minus 1. If it is true, if it is in minus 1 position, we can make or initialize front is 0, moves to first element, first position. After that, we increment here by 1. Initially here is minus 1. Minus 1 plus 1 is 0. We can able to insert first element. Right? Now the element is 10. Right? The 10 is moves to the queue with the index. So this is actually an array index, right? After that, you can get the element is inserted successfully. So this is a procedure to perform insert any value in the queue. Whereas deletion, it is like our pop operation in stack, right? Here we use front position. We don't want any parameter because it simply locate the front position and removes the respective data, right? So while removing the data from queue, we need to check whether it is empty or not, right? If it is empty, we cannot remove any element, right? Nothing is there. So if it is empty, we can display the message called queue is empty. realization is not possible. You simply terminate the function. Otherwise, it is not empty. What will happen? We need to perform front is equal to front plus 1. And we can simply delete that particular position. Right? And also check if front equal to rear. What's the meaning of that? If it is front and equal to rear, both are in same position, they have only one element, right? So ultimately, once you remove it, it goes to empty state or empty queue. So once it is empty, we can always set rear and front is -1. So this is the meaning of that. The front and rear is 1. The queue has only one element. After removing the element, deleting an element from a queue, automatically it goes to empty queue. You are familiar with that. If the queue is empty, the rear and front positions are set to -1. Right? So DQ, we don't have any parameter. You check front equal to rear, the queue is empty. Right? Relation is not possible. And so this is initial case. Right? And we can else we need to remove the element which is located by front, and we increment front plus 1, it automatically moves the front position to next position. After moving to next position, we need to check if the front equal to rear. If it is a rear, front is equal to rear, we simply set to -1. So this is the way we perform DQ operation. I hope you understand the concept. Any doubt or any clarifications from audience side?
No, sir, it's clear, sir.
Thank you. So display function, here also we need to check whether it is empty or not. Right? If the queue is empty, we cannot, so nothing is there, right? We cannot display anything. So before displaying any element, we need to check whether it is empty or not. If it is empty, we simply display empty and terminate the function. If it is not empty, we can start with one variable. So is okay, we track the front, and from the front we can display the value 1 by 1. Right? See here. Essentially rear is equal to -1. Definitely it is empty. Right? Now we need to track or display the element 1 by 1. Assume that it is the element 10, 1, 2, 3, 4. Right? So inside this front, it is rear. Right? Now we can assign I is equal to a front. So both are same. For our understanding purpose, right? We use I is equal to front. Now front is equal to I. Now I is equal to front. Now it is 0, 1, 2, 3. Now inside is 0, right? Now the rear is 4. Now we simply display the values. For example, Q of 0, it display 1, and Q of 1 display 2, Q of 3, Q of 4, right? So after that, it terminates from the loop. So this is actually a display function. So these are all the related things related to array. So array is a static, right? For simple or limited number of variables, it is perfect. Once it grows in size, it is not suitable for real-time applications because we cannot expect the data comes from various sources, right? We cannot expect the same size or limited sizes. That's what array is not suitable. In simple applications, we can use array. Now, another implementation of Q is netlist. So there is a problem in array, right? What's the problem in array? So array is a static. For example, here integer a of 5. We simply use a of 5. So we cannot extend or grow and shrink. It's not flexible to change the value. right? So we cannot insert more than 6 elements. Up to 5 we can comfortable to insert or keep the values. Beyond that 5 we cannot insert because it's a static. So before performing any operations, it allocate 5 spaces expressly for the particular operations. According to our topic, it is a queue. It allocate 5 spaces for performing queue. Within that 5, we can perform insert, delete, any operations. We cannot go beyond that limit because it's a fixed number of data values. So the amount of data must be specified beginning itself. So while declaring any variables, we must specify how many elements we need, right? So that is actually a problem. We cannot maintain how many elements we need, right? Suppose it's not suitable. So array-based implementation is not suitable. We don't know the size of the data we are going to use in our applications, right? So those kind of problems is used for some other implementations. It never uses array. So these are the problems overcome with the help of linked list. So linked list is another implementation which overcomes all the problems related to array, right? So ultimately we keep unlimited number of values. Definitely it is suitable for real-time applications, right? So we don't want to fix a size in beginning of the implementation. Wherever we want, we simply insert an element, right? So this is actually a linked list implementation. It is also known as dynamic implementation. So linked list always use pointers. Array always use variables, right? So pointer, we are familiar with that. What's pointer? Pointer is a variable which holds address of the another variable. Otherwise, you can perform address mechanisms, accessing calculations related to address. We use pointers, right? So we are familiar with that. Q is first in, first out order, which keeps 2 variables, front and rear. If it is an array, we declare as integer. If it is a linked list, definitely we create or keep 2 pointers. One is a rear pointer, next one is a front pointer. So rear pointer is a pointer which is used to give the location where our new data is stored. Likewise, the front is a way pointer to point out the element going to delete or remove from the list. Here we are consider pointers, 2 pointers. Clear? Okay. Now this is a simple example. See here, this is a pointer. So far we use only rear and front. It's a variable, no pointer. So this is all the address in memory. These are all the values, right? So this is a node because it's a linked list. We have one node. It's a single linked list. We keep the data in the first position and address in second position. This is a node structure of single linked list, right? So now this n for insertion, this n for deletion. This pointer helps to perform insertion and deletions. See here, we're performing NQ, right? So initially it is null, right? So how to perform it? So it is stored, it is a null, it is a header. Normally we keep Q, so Q is null, right? So initially the Q is null, nothing is stored, it's a header. Header point towards the first node. So if you want to add 15, what we are going to do? First to create one empty node, right? From that node, we insert 15 and set the pointer as null. Now this is a new node, right? This is a new node. Now we need to replace the pointer. The header is point out to first node. So this is happening here. Likewise, insert or add 87. This is the NQ operation. Again, we need to create a new node and insert a node. That's 87 and set to null. Now we keep this is a front, this is a rear, right? Now the rear is point out to next new inserted node. Now this is rear. Actually, this is rear, this front. Likewise, insert 24, we create a node and fill up a node with the data and pointer. So any data is a null, right? So after replacing, we change the address, right? Now 24, we create a node and fill up a node with the data and the pointer. Now the rear is moved to new node. So this is a way we need to perform NQ in linked list, right? Now DQ, how to perform DQ? This is actually after inserting 15, 87 and 24. Now we remove the first element. Which one is the first element? Because this is the first element which holds the front. So this holds the rear, right? Now, once you perform DQ, automatically it disconnected from the link and this link is replaced to 87, right? Which means that this header, the header of next is moved to temporary node. Initially we fixed this is the temporary node, right? So temporary is front. Now we remove this temporary node and we simply replace the header with new node. Now we get the list like this after removing 15, right? So after perform again DQ, automatically it removes from 87. It's a temporary node. It is going to delete by the DQ operation. Now the link is point out to next. Again, remove 24. It simply remove these 24 and set to null. Now we get the Q is set to null. So this is actually a NQ and DQ operations related to linked list. Is it clear? Any doubt from audience? Okay. Now see here. So operations, definitely we need to include necessary data files and user-defined functions, right? Now we need to define a node structure. The node contains data and address. So first to define the node and we need two pointers. For example, front and rear is set to null because these are all the pointers. Instead we said that as a null. After that we need main method to implement all kind of functions and variables and later operations, right? Now NQ, see here, this is actually a NQ. So this is a node. Node contains data and address. This is actually a representation of a node. In C, how to declare it? Structure node. We are familiar with it. Structure is a collection of heterogeneous data item because linked list node contains two different data items. So this is data, next one is address, right? So these are the different data items. So heterogeneous data items. So SOW is a structure. Now the first one is the data, always keeps integer. So for example, 10, we can keep 10. That's integer type. Now this is a pointer. The address which point towards the another node. Similar like this, right? This is structure node 1. Likewise node 2. This pointer point towards the another node. That's why the return type is structure node, right? It is not integer because one node point towards to another node, right? So initially we need to create a node. Node means we allocate some space in memory, one for data, next one for address, and fill up a node. So initially it is a 10. If you want to insert 10, 10 is data part and set to null. So this is happened in the first phase in linked list. So after that, we replace the pointer based on the list of items available in the queue. That's the linked list, right? Here we perform queue operations, implementation of queue using linked list, right? Now we need to create a node, new node, because this is structured node, right? We need to create a struct node. That's a new node. First to create a node, right? So we need name it as new node, right? So this is new node, and this node is allocated. So how to create a node? This is a declaration of the node. Now we need to allocate some space in memory, right? So structure node, these are type conversions. Semalog is a function which is used to allocate the space in memory. How much size? We need to find out the size of structure node. This structure node keeps two values. Here, integer data and pointer. So it keeps on empty space in memory. So after that, we need to place the value. For example, here it is a 10. You can simply place in data plot. Now, we set the pointer is null because we don't know where we need to place, which position we need to place, right? So we simply set to null. So these two statements perform these operations. After that, we check whether the list is empty or not. How to check the list is empty or not? If the front is null, automatically the list is empty. We can assign new node as front and rear. Now this is a front, this node is rear, right? In case of list is empty, which means that this is the first element going to insert in the queue. So next is subsequent insertion. For example, now we have 10. It's a new node. The front and rear point out the same node. Now we need to insert 20. Again, 20 is passed here. It's create a node. One node is created here. And so that is allocated in memory. Now that is a new node. Now this is not a new node. Front and rear is replaced. Now we need to check front equal to null. It's not because it is not empty. Previously we have inserted 10, right? Now these conditions get follow. It goes to else spot. Now rear is equal to new node, which means that this is a rear. Now this is actually new node. It goes to new node. Now we pass rear is new node. Now front is the rear is the. So this is a way we create a node and insert in the respective position. Initially start with the empty node. It goes to all number of elements while deleting an element. So deleting an element from a queue using linked list, we always perform dequeue, right? So queue is empty. We check the queue is empty or not. If it is empty, we simply leave the queue. We can display the message as delete is not possible. If it is not empty, we can simply assign temporary node because we have a node list like this. Assume that we have 3 nodes. First one is 1, second 2, next is 3. This is the last node. So this is header node point towards the first node. Now this is front, this is rear. Clear? Now front is null, means Now front is here, means it is empty. Now front is here because we inserted 3 elements, 1, 2, 3. Now we need to create one temporary node. Assume that is a temporary node. So that is assigned with the help of front, right? Now front is moves to here. Front is front to next. Now we need to remove this element, delete this element by performing TMP, free TMP. So free is a function which you use to deallocate space in memory, right? So in this example, there is no any header node. That's why we leave as it is. If it is a header node, you simply insert one element. For example, here the header node is Q. So we use Q equal to Q of next. Sorry, Q of next. Q of next is equal to front. Front is equal to Q of next. We can assign these two here. Now this element contains, or this list contains 2 values. After removing these. Clear? Any clarification from audience? Shall we go? I'll wait for a minute. Do you have any clarification? Please. Okay. I hope the concept is clear. Now the display, right? So how to display it? Again, we need to check if it is empty or not. If it is empty, we simply display the way Q is empty. Otherwise, it is not empty. We simply assign the temporary variable for navigation, right? So if it is null, it is empty. Otherwise, we can assign one temporary variable. So that is the navigations, right? For example, here this is first. That is a traversing. This traversing, right? So now this is a front. It is assigned to temporary. The temporary is not equal to null. Then the data is displayed. 1, 2, 3. It is null. Now it displays 1 first, and the temporary is moved to here. Loop repeats. It is not equal to null. Again, it displays 2. Again, it goes to another position. It goes on until it reaches null. So this is the procedure to insert display elements in the queue, right? And normal, so far we have discussed normal linear queue operations. One is an array based, next one is a linked list based, right? Now, some problem is in linear queue. So previously we discussed linear queue that is implemented either using array or linked list, right? Now what is the problem actually? See here, if the queue is full, front pointer is 25, rear pointer is 95. While performing deletions or DQ operations, first DQ it removes 25, next DQ 30, next DQ 51, next DQ 60. So we can get like this, right? So if you want to insert a new element, we cannot. Still, we have some more element of free spaces in queue. We cannot insert any element because the rear is in last position. Our assumption is in linear queue, once the rear is reaches at the last position, right? So we cannot insert any element. right? Because which means that there is no any further spaces. Even though we have some spaces in front end, right? So these problem is overcome with help of circling, right? We can make use of these space as well. For that, we can connect these rear to for last pointer to first pointer, which means that suppose if the new element comes, for example, 96 comes for insertion, automatically the rear is incremented by 1. It goes to here. Automatically we can place 96 here and 97 here, 98 here. So now we can keep our space in fully occupied manner with the help of circular queue, right? So normal queue, if there is any spaces occurs after removing any elements, right? We cannot insert. It leads wastage of space. So that is overcome with the help of circular queue, right? See here. So this is actually a circular queue. It's also a linear data structure. It also follows first in, first out, right? So only difference is the last position is connected back to the first position. So this is the schematic diagram of circular queue, front and rear, right? Point out the same. Assume that this is a linear queue. It point out front and rear. The queue is full. This is circular queue. The phi, the rear is connected to first element. So this is actually, right? It makes a circle. We'll see one simple example for clear understanding. See here, this is circular queue. Inside it is empty, right? Front and rear is 0. Turn inside turn. Definitely we increment rear by +1, right? And front also 1 because the front and rear point towards the first position. Inside is 0. 0, this is not a position, right? Which means that it's empty. Now, after inserting turn, the rear is front is point towards the turn. Now insert 50. What will happen? The 50 means rear is incremented by 1. Now the rear is 2. Rear point towards here. After inserting 20, again the rear is moves to here, right? Now insert 70. The rear is moves to here. Now delete, perform DQ. What will happen? What will happen? Automatically the front is incremented by 1. So front goes here, right? Now again insert turn 100. Now the rear is in fourth position. Now the rear goes to here, right? Now it is 100. Now insert 40. Now the queue is full. You cannot insert further because there is no space, right? So queue gets overflow. Now delete front. Automatically we remove 50. We get one space. And again perform DQ. Again we get space. Suppose if you want to insert, leave this, insert 101. Automatically it goes to here, right? We have performed to delete, it removes 70. So it gets circle, right? So whenever insert an element, we always insert, we occupy free spaces, and we can perform front, always perform DQ operations. Clear? Any doubt? Any clarifications? Is it
No,
clear?
sir. Yes, sir.
Yeah, thank you. So here now this is a normal implementation of circular queue. We set the constant size because here we use array implementations, use the different functions, and this is an array with the size. and initially front and rear is -1, right? Initial positions, and we need main method to implement it. So this is like our previous implementations. See here, NQ in circular Q. See here. So if the Q is full, rear is size is -1 and front is 0, right? So we cannot insert further, right? So if it is full, insertion is not possible because there is no any room to place our data. If it's not full, automatically we need to check size is -1, whether it rear reaches last position, front is not equal to 0. Then rear is moves to -1, which means that it also goes to almost full stage. And otherwise, we simply increment the rear by 1 and place the value to the respective places. See here, front is 0 and rear is -1, Q is full. The rear is -1 and front is not equal to 0. We said rear is -1 because it is in last position, it goes to previous. Because it is a circle, it goes to -1. Almost it is also full. Otherwise, we increment the rear by 1 and the value is placed in Q. Right? And check if the front is -1. We move to front is 0. Right? For further removal or deletions. Likewise, DQ operations, we check if it is empty or not. If it is empty, leave it. If it is not empty, we need to perform front plus plus and check whether front is equal to size. It reaches maximum size. If it reaches maximum size, the Q is empty. We set front is 0. And ultimately, we set front is -1. And also check the rear is equal to front -1. Then we can simply set front is equal to rear, front and rear is equal to -1. Right? So this is actually a code. -1 empty, otherwise equal to size, we set the first position. If it is -1, because front -1, ultimately we set is a -1. It's a empty conditions. Display, as usual, check the empty conditions. If it's empty, we cannot. Otherwise, if it's not empty, we set front is I. See here, we set I is equal to front, and front is less than rear. Definitely there is a value, right? So whenever the front crosses rear, front equal to rear, that's empty conditions, right? So definitely it is true. Then I is a front less than or equal to rear, and display that value. Here's the case. Suppose it is less than or equal to size -1, right? It is related to front and rear positions. This is related to last value, last position. Suppose if it is a 5, last position is 4. Print it. And set I is equal to 0. And suppose if so after that, it performs all the rear value, it checks with the front and display all the values. So this is actually a 4 cases to display circular Q. Next we have a double-ended Q. So double-ended Q is also a Q which performs insertion and deletion in both ends. Right? See here, normally we have one end, front for deletion, rear for insertion. We cannot insert or delete through rear or insert through front. Right? But in terms of double-ended Q, you can perform. We always use DQ. This is a DQ. So you can perform insertion and deletion in both the ends. So this is actually a double-ended Q. You can perform insertion and deletion in both the front as well as rear end. So it needs some complexity in algorithms. That's why we restrict some end for deletion and insertion. So for that we use input restrictor double-ended queue or output restrictor double-ended queue. As input restrictor, we can perform insertion in only one end, but we can perform deletion in both ends. And output restrictor, we can insert in both the ends and delete in only one end, either rear or front end. Right? So this is actually a double-ended queue. We'll see. So it is a little bit different from the previous queue operations, right? So insert at front, insert at rear, deletion at front, deletion at rear, because we have both ends to perform insertion and deletions, right? So insertion at front, insertion at rear, delete rear, right? So these are the four possible operations we have to perform over DQ. So DQ is nothing but these notations. Normally we use DQ, DE, QU, UE, DQ. This is a deletion operation. Here it is double-ended queue. This is notation for double-ended queue. Right? Now insertion at the front. It is very, very simple. First to check whether the queue is empty or not. If it is empty, both front and rear are initialized to 0. Right? Otherwise, we need to check the front is less than 1. Right? So if it is less than 1, we reinitialize to n. See here, you better understanding, you can see these diagram. So front end, the insertion at front. So 7, 3, 1. Right? The rear always insert the value. Right? Now, if the front is 0, if it is not empty, front is 0. Automatically, the front is moved to last position. Now, from that, we can insert the element. Clear? If front is 0, we reinitialize front to n-1, this position. After that, we can insert 5, and front is front minus 1, and here 6, now front is here. So this is the way we insert through front end. See here, insert front, the front is 0, rear is size minus 1, overflow, and f is equal to minus 1, r is equal to minus 1, it is empty. So this position, right? We move the front and rear here and insert the value into the queue. And if f is equal to 0, front is 0, automatically that is moved to n-1 and place that value. Yes, front is equal to front minus 1. Clear? Clear?
Sir,
Yeah. Clear?
sir,
Yeah.
sir, can you explain the cells if f is equal to 0,
Yeah.
f is equal to size minus 1, that step alone, sir?
This one. Yeah.
Yes, sir.
Yeah. Just a minute. Essentially, array is empty, right? Array is empty. Now we insert 7. Insert it. So front and rear here. Rear and front. Now again 3. Rear moves to here. And again it is 1. Rear moves to here. Right? Front always here in 0 position. Clear? Now we cannot insert element after 2 because we need to perform modulo operations. Right? So for that, we check the front is 0. If the front is 0, we need to move the front to last position here. And again, we insert our element. Now, the space is here 50. So this is happening. So here, Initially, we check whether the key is empty or not, right? So front is equal to 0 and rear is size minus 1. Every is overflow. Nothing is there. So it's overflow. Now, we need to check if it's not overflow. F is equal to minus 1 or is equal to minus 1, which means that it is empty, right? Now, we simply move to the first position. We can place our data in. Now, so this is a case. Now, these cells is related to these keys, right? Now, front is 731. Now, we cannot insert further. We need to move the front position, right? So, we need to check whether front is 0 or not. So, 0th position. If it is 0, then we can simply move the 0, the front position to last position. From that, we can insert in reverse direction. Clear? The 0 size is minus 1. We can place here. It is a first position for the front after de-initialize it. That's element 1. Now, we can place a new value, right? So again, if you want to insert 6 here, what will happen? Definitely, we need to insert 6 here. Again, it checks, it is not overflow, it is not minus 1, it is not 0. Now, it goes to this else. Now, we decrement to 3. Now, it is 4, 4 minus 1, because that space is here, right? Now, F is equal to F minus 1. The front is moves to the previous position and we place 6 here. Clear?
Yes, sir.
Okay. So insertion at rear end. Same way, we insert 731, right? So that is incremented by 1. Because everything is rear end, we can simply perform rear end. So we check the overflow, and if it is 0 empty, we can move to 0th position. If it is equal to the size 0, we can move to 0th position. Always we increment it by 1. It is equivalent to simple insertion operation in Q, right? And deletion at the front. It is a little bit different. If the Q has only one element, we can simply set rear is minus 1. So we make the Q is empty. And the front is equal to rear. That also removed is set front and rear is minus 1. This also makes the Q is empty. Now, because this is actually a front end deletion, right? Now, if front is equal to size minus 1, automatically the front is here. We suppose the element is 10. Now, this condition, F is equal to size minus 1. We remove it and front is moves to 0th position. Suppose none of the condition is satisfied. Automatically, some value is there. The front is always moves from one position to another position for removing an element. Right? And rear end deletions. Previously, we use front end deletion. Here it's a rear end deletion. Now, this is actually a empty condition. And this is one element. Remove it. R is equal to 0. Now that element is 0. Right? Rear is 0. Now what will happen? We move re-initialize to size minus 1 here. Right? So that's the case. We perform R minus 1. Right? So right. So priority queue. So previously we simply insert and delete any element based on the conditions, based on the constraints. Now we apply some key value pair, so ordered key value pair. That key value pair gives the priority over the value. For example, here lowest value at the front and highest value in the rear. Otherwise, we can use lowest value at the rear or highest value at the front. Ultimately, we need to assign a priority over value. So based on that, we can assign or insert delete the elements. So these are the operations, normally insert operation, remove operations. Now peek. We don't know where our pointer is there, right? Where to pick our element. So that is peek, gets the element from the front of the queue. If it is full, we check is full condition, is empty, checks whether the queue is empty or not. So here, now we insert an element, we check it is full. So if this item count, it's the number of elements, right? So first insert the data into the queue, right? Since it is a empty queue. If it is not, the queue is not empty, we need to check the data is larger because we need to arrange in some order, right? If the data is larger, we need to shift in the right? Suppose here it is, now we need to insert 12 or 15. Initially we have 12, 1, 9, 5, 3. If you want to insert 15, we need to move towards right and place that element. Right? So simple comparison operation, we can shift it. Now we can insert the element. Likewise, DQ operations, we simply perform. Right? Simply remove the count, item count, we can simply remove the element from the queue. So application of queue, job scheduling, there are multiple jobs in main memory, right? Because jobs are most main memory for processor execution. Now we need to keep some order. It's a first come first serve order. Let us take the printer. Right? We have only one printer in our laboratory. So the first print gets printed first because it's a spooling concept, right? That also follows queue and multi-programming. So multiple programs run in memory. So that also follows in queue order, right? There is a ready queue. So once the job is moved to ready queue, then you can easy to run it. So there is some scheduling process, right? And shared resources, so single machines. In terms of network, we have only one server. The server is served multiple clients or request to clients. So that is also based on the queue, right? So thank you. So that's all about the queue. Any doubt from audience side? Any doubt? Any clarifications?
Thank you so much, sir. We had great
Thank you,
session with you.
Thank
We were
you,
able
ma'am.
to learn a new double-edged extra.
Thank you, ma'am.
Thank you so much, sir. Professors, if you have any doubts, you can ask Saravanakumar, sir. I hope no one has doubts, sir. Once again, thank you so much for spending your precious time with us, sir.
Thank you, ma'am. Thank you. Thank you, participants. Thank you.
Thank you.
Thank you very much.
Thank you, sir. Professors, you can go for a break and join the next session by 3 p.m.